All right. So let's see if we can't clean up some of this MathML. We previously talked about this guy up here, didn't we? And the sort of issue that we are dealing with in terms of the math number tag versus the math text tag. And what is the issue? Well, the issue is that for some reason here that I'm not exactly sure, I've yet to reach out to the development team, the Pages development team at Apple, to find out exactly why and what's going on. But mtext is font family preserving for the document, while mnumber is not. Okay, so just to recap, I've got the font family set to Latin Modern Math or Latin Modern Roman, mainly depending on line spacing issues. Issues regarding white space, but it's an aesthetic issue. It's like a runtime issue. It's not really a concern outside of just typesetting preferences. So what I would like is for all of the text, including the mathematics markup, to be consistent in terms of typeface. But as we've discovered, that's just not the case in terms of math number, okay, for number indicators, or for number tags anyway, number elements, number items, whatever phrasing feels most appropriate, versus the mtext. So let's just look here. I've made some corrections over here for this script. Okay, for this element. So what's the issue? Let's have a look, and then I'll go over exactly my solution for this problem. So if I simply change this to math number as opposed to math text for this number, actually I should do it for the 2, not the 0, or 0.0. So let's do it in here. So in here we have, under the replica bar, the digits 2 and 1. Okay, so 0.021. If I go in here and I change the tag from mtext to mnumber, which is syntactically, whatever way you want to say it, either more correct or more appropriate. So we're cheating a little bit by not doing this, but as you can see, it changes the typeface from Latin Modern to presumably Times New Roman. So I'm going to try and figure out, if I can, from someone over at Apple, why this is the case. We'll see if I get an answer. Because as we'll see later on, and I think I might have already shown this in one of the videos, if we do this markup just on an HTML file, or in a text editor with live rendering, such as Whisk, which is what I use, or you can even do it in Visual Code. Okay, it also has live rendering for HTML. There is no discrepancy among the tags, so they are in fact universally typeface preserving. So we're not going to run into that issue. Whenever we're sort of sketching around, I suppose, in Pages, or maybe you're working with Microsoft Word, I don't think you'll have this. I'm not totally sure, but I would imagine that you won't have this issue in Microsoft Word. I think Microsoft Word has been integrating MathML for a number of years longer. in a sort of more complete sense, or in a more complete, with more completion. So we'll find out if that's the case. I might play around with it later on, but I'm mostly concerned about pages anyway, and in the case of pages, it is in fact an issue. So what can we do about it? So my solution for now, I've tried a bunch of stuff. I've tried a bunch of ways, a bunch of workarounds here, but my solution for now is simply having these tags fencing the actual digit, the actual tags enclosing the digit be mtext, math text, and then just simply having some attributive annotation in the annotation space here that lets either the reader or in the case of a symbolic computing engine, know via this semantic information what is actually intended. So it's like an override instruction. So it's like, yes, even though I'm instructing the rendering engine to compile this on screen as a text element, in the context of computing its value, treat the numeral as, okay, I'm just hovering with the top part of my cursor here, just below. Okay, I'm not hovering over the replica bar here. I'm hovering under numeral. Treat or compute the numeral as a number, as opposed to a text token. Okay, so that's the solution. And we'll come back to this example here in a second. Let's see if we can't clean up some of this other stuff in that same context, and that's using that same method. Okay, so this is what we're working with here. And again, we want to make sure it's going to be a little bit less obvious visually because, again, we're just dealing with mainly the difference between Times and Times New Roman and Latin Modern is the rendering of the serifs. Okay, so let's start by getting rid of this guy here. This is just one of the things that I was trying to see if I could get it to work the way I need it to work. And what you'll notice, again, going back to the other one is, like, why not start with annotation right with the math tags. So, okay, so in this case, we might give it a name, but you don't have to. The actual text, the actual math element here. And so what might we call this? Sort of list of terminating decimals. Might come back to this, but just so that you can see. So we might come back and give this a better name in a moment. Yeah, might come back and shorten that in a second. All right, so the first thing that we're going to do here, and again, this is going to be much easier to see with numbers, digits that have a bit more elongated serifs. So it's not going to be totally apparent, totally obvious for digits 0s and 1, but we're going to do it all the same for consistency. So mtext, all right, and we're going to say compute numeral as number. All right, that's what we want to do here. And the sort of added benefit to annotation, to MathML annotation, and really in general markup annotation, is that it helps with writing what you might call beautiful code or elegant code. Okay, something that's visually pleasing in such a way that it's more easily read by a human and ultimately also by a computer because of the annotation. What we mean, right, in the sense of WYSIWYG, or WYSIWYM, really. What you see is what you mean. Okay, so that's an added benefit in terms of markup annotation and the actual resulting code block. Okay, so and when it comes to equals, I kind of care less. I see. I'm not sure. I'm not totally sure how that happened, but no problem. Let me just find the syntax error in here somewhere. Okay, there we go. All right, so far so good. Okay, and you can tell. I mean, it's what we have down here now, rendered by the engine WebKit, is in fact Latin Modern Roman. Okay, as opposed to what it previously was, Times New Roman. All right, so that's what we're aiming for here. And then, of course, we'll just sort of flesh out the code block a little bit here. And what I've started using for the operators, it's a variety of annotation options. But I think what I've got below for the other element is, I think I have it like something like this. We'll double check in a second. Might be the other way around. Actually, I think I have, yes, I know what I have. So I'm going with a grammar annotation as opposed to a computable or a computational annotation. So I'm actually going with coordinating conjunction. And there's some reasons why that I'll elaborate on as we go along. But basically, we have options. This is another sort of, inherited benefit that we can just take advantage of. So in our annotation scheme, we can either choose to incorporate or include syntax annotation, semantics annotation, or both. Or as a tertiary option, I suppose, computational annotation, which itself has, yet again, the options of computational syntax or computational semantics. So at minimum, you have 4 choices for each annotation expression in these tags. So you really have an infinite space to work with in terms of making your code look good and rendering really clean and consistently computable MathML. This is not the case with LaTeX. You do not have, not in the same way, certainly. Okay, LaTeX is not a context markup language. It is a presentation markup language, right? Just to recap. But what is it creating? LaTeX produces images. Okay, it's producing an image as opposed to UTF-style characters. All right, let's go to the next element here. And there's no tab option. I'm hitting tab right now. So if you're wondering why I'm sort of doing this sort of brute force indenting, to my knowledge, there's no tab option in the equation editor for pages. So another thing that the developer team might want to consider improving in later versions. And again, I'm working here with macOS Monterey 12.71. So these comments that I'm making with regard to the capacity of any of these systems are in the context of this operating system version. So just like to point that out every time or as often as I possibly can so that folks who are working with earlier or later versions don't find themselves, essentially don't find discrepancies with what I'm saying. All right, so what do we have here? So this is our first fraction. So that's this guy. Now what can we do here? What we can do is, okay, so that's actually fine, numerator, denominator. Okay, so that's fine. All you do now is include our annotation, compute, numeral, as number. And that'll be the sort of consistent thing that we'll do here when we're working in pages, which is essentially our notebook, right? This is sort of as a way of developing some intuition for MathML. Later on, when we're actually writing our web pages, okay, guess I might as well just show it quickly. Later on, when we go back to doing this stuff, right? Here, so when we're developing this for actual web pages, we'll be using a different editor. This is not going to be running from, right? These index files are written. Okay, so this index file, I'm using 𝗕cie. Okay, VS Code just as well. Xcode fine, but 𝗕cie has live rendering and it's lightweight, so we'll come back to showing that again. And as I said before, VS Studio is also an option for doing the markup and live rendering, live preview. Okay, just wanted to point that out quickly. So getting back to this. Right, so we've got that. So far, so good. Now this is fine, as is. But instead of using fixed space and non-breaking space, I might actually do this instead of it. I like the element length. But let's try something. So that's too much, right? So I think what's actually enough is maybe even less than en. And en looks good. It's a little less than what the previous, right, thick space and non-breaking space. So I forget what the n stands for, but yeah, so HTML, XML/HTML offers a number of options for creating white space. And so recently I've come across EM and EN. And so I like that it's just more concise code-wise, but we might give it some annotation to flesh out the row such that it lines up here as best as possible. So what might we give it? I would say just punctuation true, or yeah, separator. So that's perfect. Okay, so separator and it's true. I'm pretty sure this is HTML/CSS. I sometimes forget where I get the annotation attributes from. So this particular attribute, I believe, is HTML standard, HTML/CSS standard, but it's possible that it actually is a MathML standard. Actually, this one I'm pretty sure is HTML/CSS standard, separator true. Later on, you'll see me working with the form of an operator such as plus or minus. In that form, the attribute value would be either index or prefix, infix rather, or prefix. So infix in the context of, let's just say I'm adding a binomial, a plus b or something, right? So that plus would be considered infix, and in the context of, let's just say, for example, minus a equals b, that minus on the left-hand side of the equation, that minus would be a prefix to a, right? So that would be that, and so we'll see it later, but I'm just sort of touching on it now, I suppose. That attribute would be considered form prefix in the case of minus a. Okay, so just a quick comment on attributes in the various places where they show up. Here again, we're dealing with a number, right? So we're telling just to sort of reiterate the reason why we're doing this, mtext, when it's supposed to be mn, right? That's what it's supposed to be. It's a number. It's a math number. That's the appropriate and syntactically valid tag that we should be using here. But the problem is this version of WebKit for Pages, okay, and actually maybe I should be looking at, this is what I should have shown. This is Pages version 11.1, all right, whatever this number refers to. Okay, so this is version 11.1, maybe it's this particular release. Okay, not sure exactly. So Pages 2005 to 2021, and this recording, I'm recording this video January 5th, 2024. Okay, so clearly it's not the latest, greatest version of Pages, and I'm not sure how many releases there have been since this one has come out, but in this particular version, all right, we have this issue that math number tag is not font preserving. It is not typeface preserving. Okay, so that's why we're doing this manipulation. All right, and we get what we want. let's just see if we can actually tell the difference. All right. Can you tell the difference? It's on the serifs for the 1 and the zeros as well. Okay, it's super subtle. In fact, yeah, for the 1s, it's so subtle. I mean, you can barely see it. I'm not even sure if I'm seeing it, but I know it's the case for the 2s. Okay, so but yeah, on this 1, I'm not seeing it, and it's very possible that it could be. Let's do this. Let's just throw in a 2. So let's do this. Let's copy this. All right. Let's revert to the math number tags. Let's throw in the 2. So now we can see. There's no bulging serif on the 2. Okay, I can make this. See how much bigger I can make it so that. Yeah, it's not really scaling the. Not really upscaling the rendering. So fine. No big deal. All right. So there you go. So the 2 is not, the math number does not preserve the Latin modern math typeface. That's why we're doing this. All right. Now if I put that 2 in here now, boom, you can see it. So hopefully that's clear enough. Let's get rid of that 2. Let's add our attributive annotation. Compute numeral as number. And now we kind of can just finish this up, can't we? Junction. Okay. That's my sort of go-to attribution for equals. So you'll see me use that quite a bit. Okay, and so for this guy here, when we get down here, let me see. Okay, so let's finish this guy up. All right. So for this fraction up here, I think what I'll do is add the attribution or the annotation display style. No, not display style. It tends to be for characters more. So display inline. All right. And maybe more to say on that later. Okay. Good there. I like all of that. Again, display inline. Easy enough. Okay, and so here we need to do a little more cleaning up. Okay, starting to get a little lengthy. But this editor is like almost perfect, isn't it? Just in terms of the bare minimums for just, practicing in MathML. I mean, like I said earlier, we'll there's so much that we're going to be doing with MathML, but just for getting our feet wet and getting into the business of MathML, this environment I think is just fine. Okay. Compute number, compute numeral as a number. Okay. We're telling the rendering engine. We're communicating with two engines. We're communicating with the rendering engine, WebKit, in the case of working on a Mac, and we're also communicating simultaneously with any symbolic computing, or for that matter, numerical computing engine that might be running any kind of computation on these elements. So maybe that's Mathematica. Maybe that's in old school Sage Math. All right, if you remember Sage Math, formerly Sage Math. Well, I guess it's still Sage Math, but which is the underlying engine computer algebra system for CoCalc. If you're familiar with CoCalc, Sage Math. Okay, Maxima. All right, Jupyter. Okay, whatever you're working with. Any kind of symbolic potential, or large language models for that matter. I have a lot more to say about large language models and how this style of doing mathematics will relate to training large language models down the line. Okay, at the moment, most, if not all, large language models are primarily trained on LaTeX, mathematics content typeset in LaTeX. Why? Because that's the language that most people are using. MathML is considered a machine language, a low-level language. Okay, because it's considered to be hard to read for humans. But what we're doing here, as you can hopefully tell, is that we're trying to demonstrate that that is not necessarily the case. Yes, MathML is a machine language. It's in the context of it being low level. Like, we're specifying every character. But what we're discovering now is that in annotating those specifications, we're actually making it, rendering it, no pun intended, a high-level language, making it such that it's legible to humans as well as computers alike. That's kind of the discovery here as we progress through these exercises, okay, through this course, this program in MathML. Okay, so we're good here, and again, I prefer this guy, so that's what we'll use. And let me make sure that I have it in the right. Yeah, that's perfectly fine. Okay. All right. Now, why is this equal sign here again? I'm not necessarily saying that I'm catching all of the little syntactic stylizers, but I think I'm catching most of it. So let's just see, where is that? So that's, okay, so that position is fine. Great. All right, so what do we have here? Once more, compute numeral as number. So this should be totally obvious now why we're doing this. And here we have close any conjunction. We'll see a lot more. I have a lot more to say on this sort of natural language grammar and why it's useful as we progress. All right, and then lastly, display inline once again. Okay, might have some more annotative material for fraction tags, these fraction elements. Later on, we'll have to see. We'll come back to that. And then let's see here. Let's do, once again, okay, you should be able to sort of know exactly what I'm doing here now. And that's it. All right. So much cleaner than what we had before. We're preserving our font setting of Latin Modern Math. And we've given some context. We've given some semantic content. Okay, we've created more context for the human reader, anyone who's reading our code, our markup for these mathematical expressions, and the computer itself. In the case of, once again, the mainly the symbolic computing engines such as Mathematica, Maxima, Jupyter, Sage Math, and so on. Okay, those would be the primary contexts in which this would matter. And then I'll show, we don't really have to worry about that when we're typesetting this stuff in just a normal HTML file. We don't have to worry about this. But yeah, as we've discovered, in the context of at least Pages, Apple's text editor, primary text editor, something that we found we have to worry about. So there you go. So let's update this guy, save this guy.